There is a substance buried in the soil of the moon that, in theory, could be worth billions of dollars per ton. Not gold, not platinum, something far rarer. It is a tiny, almost weightless isotope of helium that humans have been chasing for decades. It is, in theory, the perfect fuel for the clean fusion energy that the entire energy industry has been trying to build since the 1950s. A few hundred tons of it could power the entire planet for a century, without carbon emissions, without long-lived radioactive waste, and almost all of it on Earth is gone. But it isn't gone in the solar system. The moon, according to data going back nearly 50 years, has accumulated this material in its surface dust, layer by layer, over billions of years. Whoever figures out how to mine it first may not just be the richest company in history. They may control the energy future of the planet. This is the story of helium-3. Helium itself is the second most common element in the universe. Most of it is helium-4, the familiar version that fills party balloons and cools MRI scanners. But there is another, much rarer form. Helium-3, a version of helium with one fewer neutron than the common kind. It is the same element with subtly different physics, and that difference matters enormously. Helium-3 is one of the cleanest possible fuels for nuclear fusion, the process that powers the sun, and that for nearly 70 years, scientists have been trying to recreate on Earth as a source of unlimited clean energy. Most current fusion research uses deuterium and tritium, heavier forms of hydrogen. They work, but they also produce dangerous neutrons that damage reactor components and create some radioactive waste. Helium-3 fusion is different. When helium-3 fuses with deuterium, it releases enormous energy and produces far fewer neutrons than conventional deuterium-tritium fusion. The reaction is, in principle, dramatically cleaner, safer. The problem is that helium-3 is, on Earth, almost impossible to find. Helium-3 is produced naturally by the solar wind, the constant stream of charged particles flowing outward from the sun. On Earth, our magnetic field deflects most of the solar wind. Our atmosphere absorbs most of what gets through. Helium-3 simply does not accumulate here in usable quantities. But the moon has no magnetic field. The moon has no atmosphere. For more than 4.5 billion years, the moon has been hit directly and continuously by the solar wind. A fraction of the helium-3 carried by that wind has accumulated in the lunar surface dust, the regolith, the fine, broken material that covers everything. Over billions of years, that adds up. Estimates vary widely, but the moon could contain potentially up to a few million tons of helium-3, enough, if fusion technology ever works, to power human civilization for hundreds, possibly thousands of years. The first samples of helium-3 in lunar regolith were detected by the Apollo missions decades ago. Every sample brought back from the moon has confirmed it. The treasure is real. It is just very, very hard to get. If helium-3 is so valuable, why hasn't anyone mined it already? There are 3 reasons. The first is that fusion technology still does not work commercially. Despite recent breakthroughs, the National Ignition Facility in California achieved a small net positive fusion reaction in 2022. The world still has no operational fusion power plant. Until we do, the demand for helium-3 remains theoretical. The second is that extracting it from lunar regolith is extraordinarily difficult. Helium-3 makes up only about 10 parts per billion of the lunar surface. To get a single ton, you would need to process roughly 150 million tons of regolith. That requires industrial-scale mining infrastructure on the moon, something humanity has never built anywhere off Earth. The third is getting it home. Even if you successfully extract helium-3, you then have to transport it back to Earth, a logistical chain that does not yet exist. For all these reasons, helium-3 mining has, for decades, been a hypothetical industry, a treasure waiting for the right technology. That is starting to change. In 2007, China's chief scientist for its lunar exploration program publicly stated that one of the long-term goals of the Chang'e mission series was to investigate the moon's helium-3 resources. Since then, China has landed multiple robotic missions on the moon, including a sample return mission, Chang'e 5 in 2020, and the first successful far-side landing in history. China has openly announced plans for a permanent crewed lunar base by the 2030s and has stated in official documents that helium-3 mining is one of the long-term objectives. The United States, through NASA's Artemis program, is planning a permanent return to the moon, with the first crewed surface landings expected later this decade. Artemis does not officially target helium-3 as a primary goal, but the infrastructure being built, habitats, surface power systems, regolith processing test beds, could be adapted for it. India, Russia, Japan, and the European Space Agency all have stated lunar surface ambitions in the same time window. A growing number of private companies, some American, some Asian, some only recently formed, are openly targeting helium-3 as their long-term business case. They include startups developing regolith processing equipment, mining robots, and lunar transport systems. The moon is, very quietly, becoming the most contested piece of real estate in human history. Helium-3 is not the only resource on the moon. The moon also contains water ice at its poles, which can be converted into oxygen and rocket fuel. Rare earth elements are embedded in lunar rock. Iron, aluminum, and titanium are abundant. And the moon's low gravity makes it an extraordinarily cheap place to launch material into space compared to Earth. If a real economy ever develops on the moon, helium-3 may be one of its highest value exports. But the broader picture is bigger than any single resource. The country or company that establishes a permanent industrial presence on the moon first will set the rules for how the rest of cislunar space is used. It will own the supply chains, the launch infrastructure, the safety protocols, and possibly the legal frameworks for everything that comes after. This is why helium-3 matters. Not because the fuel is the prize, but because chasing the fuel forces the build-out of an entirely new industrial frontier. A few hundred tons of dust scraped from the surface of the moon and refined back on Earth could, in principle, power the entire planet for a generation. That is the dream. It is also still today a hypothesis. The fusion reactors do not exist yet. The mining infrastructure does not exist yet. The supply chains do not exist yet. But the geological resource is real. The strategic interest is real. The race is starting. The next industrial revolution may not begin on Earth. It may begin on the soil of the moon. And we are, right now, watching the first chapter of that race quietly begin.